Hi guys, in this video we are going to start section 3.2, which is complex numbers. So let's just do a couple of problems from this warm-up. These are all problems that we've completed in the past, or we're able to do. So we're able to take the square root of 9, which is 3. We're even able, let's look at letter D here, where we can split up the radical top and bottom. Oops, I should say 4. And then evaluate each piece, so that's going to be 2 over 3. The one thing that we haven't really looked at is letter F. So when we have a negative inside the radical, actually going back to C, I think we've seen one example on the homework where if there's not a negative under the radical, but there's a negative on the outside, then you just evaluate the radical if you're able to simplify it. And that one's -2. But when it's inside the radical, that's when the negative's inside the radical, that's when we start having some problems with evaluating it. So the reason why is let's look at the square root of -25, for example. Well, some of you, if you're not careful, you might just think that, oh, that's -5. But remember what a square root means. A square root means that we're undoing a square. So think about what number would you square to equal -25. Well, if you square 5, that will be positive 25. And then if you square -5, that's also positive 25 because a negative times a negative is a positive. So in short, there are not any real numbers that would work that could go in this box here because there's nothing that you can square to equal -25 or any negative number until mathematicians invented a different type of number, which is called the imaginary unit. I will always remember the first year that I taught this without a little bit of warning that students were like, what are you talking about? They made up a number, they made up a number system. Well, if you think about numbers in general, we made up all of them, the counting numbers. Like somebody just sat down in history and decided that we're going to assign, when we're counting things, we're going to assign it different values. And so it's a similar idea, but this is harder for us to wrap our minds around because for all the numbers that we've dealt with so far, at least most of them, they're countable. We have some sort of application, direct application, even like numbers like 1/2. Well, we can take 1/2 of something, most things, and it makes sense. But and I think the terminology imaginary is a little bit hard for students to grasp too because it's the word imaginary. So, but the important thing is that the definition of an imaginary number is this right here, is where we have the letter I. I means something very specific in math, and it means the square root of -1. So if we define I to be the square root of -1, we can start evaluating radicals that have a negative inside of it, or that have a negative number inside of it. So just a quick chart to kind of show you what numbers, what the complex numbers or imaginary numbers. So imaginary and complex are, one and the same. Everything that we've talked about so far, actually in all of your math classes, even up to this point and before, we've been dealing with the real number system. So we've even talked about irrational numbers. That was pretty recent. Fractions, integers. Integers are whole numbers and their opposites. The whole numbers are 0 and all the natural numbers. And then the natural numbers consist of your counting numbers except for 0. So we've always dealt on this left side. Well, now we are introducing imaginary or complex numbers. And notice how all of these examples have the variable, which actually it's not technically a variable because it represents a number, but it has the letter I in it. Okay, so when we're evaluating square roots of negative numbers, there's really just one additional step here, and it's not difficult. It just is gonna be a little bit odd at first. So what we want to do anytime that we see a negative under the radical is we want to separate that negative out because we have a definition for it. So just like when we were separating perfect squares out, we're going to separate the negative part out. So we're going to write the square root of -1 times the square root of 25. And remember, the product property of radicals states that we can do this because if you have two radicals and two of the same radicals and they are multiplied together, then you can write it as 1. And so the opposite of that is true if you're going the other way. And we practice this when we're simplifying radicals. It's just we've never dealt with a negative number before. Well, by definition, the definition that you wrote up here earlier, if you separate out this -1, well, you can replace that with I. So that's what we're going to do. And I is, again, that's the square root of -1. And then we know what the square root of 25 is. That's 5. And I'm going to rewrite this because we typically write the real portion first and just write that as 5i. Okay. So for b, we'll do the same thing. Let's separate out the -1. Now 72 is not a perfect square. So it's I for the square root of -1, and the square root of 72, if you look at your perfects chart, separates into the square root of 36 times the square root of 2. So that goes there, and that goes there. And then just rewriting this. So again, the real portion usually goes first, and the radical usually goes at the end, any radical. So I moved that there. I gets brought down, and then the square root of 2. Now, is it wrong if you write it in a different order? No, but this is just how you'll typically see it. For C, -5 just gets brought down. And then I'm going to switch the order this time. I'm going to write 9 and -1. So that's what the square root of -9 turns into. And we have -5. Square root of 9 is 3. And square root of -1 is I. So -15i. Okay. So a complex number in standard form has a real part and an imaginary part. So you saw this in the previous chart, but here's another chart. Here's your real part. Under 2 right here is the real part. Your imaginary portion is the 3i. So that's all that this is saying here. If A is 0 and B is not 0, then we have something called a pure imaginary number, which means that there are no real portions to the imaginary number. Remember, a real number is anything that doesn't have I in it. So a real number is any number without I, or an imaginary portion. So these two pieces are your real portions, and then your pure imaginary numbers just contain an I. There's no real portion. So even though that's -4 times I, we view that as one term, and that's a pure imaginary number. So the second example, and this is the last example we'll do, and we'll continue on Friday with complex numbers, is where we solve for x and y. And what we want to do, I'm going to color code this, and I would suggest you do this. We're going to match the real portions, so the portions that do not contain an I, and we're going to match the imaginary portions. So the real portions I have in purple, and the imaginary portions I have in green. So for the real portions, we just set those two pieces equal to each other. So 2x is equal to 10, and then x is equal to 5. Okay. So for the imaginary, so we're going to set -7i is equal to yi. Well, I, remember, is a number, just a number, so we can divide both sides by I, because again, the goal is to solve for x and y. So the i's cancel out, and y is just -7. Okay. So let's generalize that. I know that seems a little bit weird. In general, if you have two complex numbers, which is what we have in this example, okay, A plus BI and C plus DI, they are equal only if the real portions are equal to each other. So A and C are the real portions, and that says B and D. I got cut off. And the imaginary portions are equal to each other. So that's exactly what we did. We set the real portions equal to each other, and we set the imaginary portions equal to each other. And yep, that's all we're going to do for today. I'll post the assignment on Google Classroom.